Hello and welcome to another OpenGL, SDL and C++ tutorial. In this tutorial we will render a simple animation. Okay then, so first of all we need to create the animation, that's why I am in Blender. So first of all I have to make an animation, but I'm not so good at animating, so I create something which a program can do and I don't have to do anything, just press a few buttons and it still looks good. I think the close animation, which looks kind of cool, and it's done by the program, not by me. Okay, so to do the close animation we need first create a close. So I press space and I press plane. This plane will be our close. Okay, I go, so I use this arrow to move it. So I move it up in the z-axis. I press S to scale it and I make a little bit bigger. So that's kind of cool. I go into the tab with edit mode. So as you can see now you can use the vertex to, rotate it and do something with it. Just press Ctrl Z to undo that. Okay, I press A to deselect and select everything, and I use W subdivide, and again a few more times. Okay, obviously the more the subdivision, the nicer animation you will get. I think that's kind of cool in here. I could press the W and subdivide a few more times. By the way, this is the new interface if you haven't noticed that. Okay, now I have to go to the physics tab. This will be the physics tab right here. I press the middle mouse button to scroll this little thing, and here I find it so many times, and it just haven't seen. The last was a particle for me, and yeah, I cannot find it, and I have to actually look a tutorial how to get this physics tab in Blender. Okay, but I found it, so I just press the tab again to go out from edit mode, and I use the close. Okay, that's it. Now this thing is a close. This plane is a close now. Okay, and I just go to close cache, or I have to find it too. Okay, self collision, that's it. If you increase the quality, obviously it will be better. Okay, I enable the self collision because it looks kind of cool. Okay, now I go to this little cube and I use this collision tab right here. So here everything will be good. Okay, and now I go to the close sketch and I press the bake button. And nothing happens, it seems, but I think it is happening, just we can see it. Okay, I will be back as soon as it's finished. Okay, it's finished. It seems that nothing has changed, but when I press the Alt button, Alt button, and the A at the same time, as you can see, this close just, that you can see what in there. So this is the close animation, pretty simple, pretty quick, and I will not take the time of this tutorial to model too much. Okay, so I just export this animation out. By the way, you have to use the new Blender version. I tried it in Blender 2.49 to export the object as an animation, but I found a little bit of problem because it just exported one static frame in 250 frames, but the same frame. Yeah, I don't know if it's clear or not. So basically you have to use the new Blender. Okay, I go to File, Export, OBJ file. Okay, I go to my desktop. Here it is, and actually I create a new folder in here. New folder, I said. Okay, so I create a new folder and I call anim, like animation. Okay, and I put this animation inside there. So desktop anim, that's right. Okay, now we need to change a few things in here, like press this animation button because we want to export an animation. Okay, normals, we don't need high quality normals, UVs, we need materials. Okay, everything other is probably good. So I call this close.obj because why not. Okay, and I just press export. Now it will export 250 frames to this anim folder right here. As you can see, it's exporting everything as a separate file, everything. Okay, I admit this is not the best solution and not too memory efficient, but yeah, it does work, and it's simple, and later on we will try to use linear interpolation for that and only store the keyframes. But for now, this will be our animation method. By the way, you can set the number of frames. I don't know how in the new Blender version, but in the older Blender version you have to just find in here, yeah, that will be it. And in here you will find something, yeah, here it is, the end frame. So you set 500 and there will be 500 frames. You can change the FPS too if you want. Actually in a game we use 30 FPS in a second, so 30, but that's not really matter right now. So I can exit from Blender and go to my text editor. Okay, and now we can implement this load animation function. I will implement it in the function.cpp and the function.h. So let me create the prototype for it. So void load animation. Okay, this will return a void. We don't really need return value, and actually we return but with a vector which will pass with a reference. So we pass the vector like that, so std vector unsigned int. Okay, and this vector will contain all of the frames one by one, so actually just the ID of them, because the object loader will return with this unsigned int, so that's why we use unsigned int in this vector. And actually it will be a reference because we want to change the value and call it frames. Okay, the next parameter will be the file name, so this will be a string, so string, and this will be the file name. Okay, we need an integer which will contain how many frames do we want to load, so unsigned int, or you can use signed, it's not really matter, and num, I just call it num. Okay, and the last parameter will be an object loader reference, so obj loader reference and obj. Okay, you're probably wondering why this last parameter, this object loader, is here, why we cannot create an object loader inside this function, because all object loader is do the same exactly. There is a load member function which if we call, then you know we can load an object. That's because in the object loader, whenever we load something with this load, we store it in this textures and this lists vector. And whenever the constructor of this object loader is called, we delete these lists. So we delete the textures and the list. So if we will create a new object loader inside this load animation function, then whenever the end of the function, the destructor of this object loader will be called, and these objects which we have loaded would be deleted. We don't want that, so I will give this object loader to it from the main function. Later on, obviously, this will be in a class, and then we don't need this object loader parameter because we can use the private object loader member variable. Okay, now we can start to implement this load animation function. I just copy it to save time. Right here, I said right here. Okay, and first of all, let me create a temporary variable. This will be a char array, so tmp, and just contain 200 characters. This is probably more than enough. Okay, and now I want to go over all of the frames. So for int I equals 0, I less than num, I plus plus. You know what? Actually, no. This is like that because the first frame is the 1 and the last frame is the number. I will show you what I mean. So if I list out the files in here in the terminal, as you can see, then we have 250 frames, and the first frame in here is actually start with 1, not 0 0 0 0 0, but instead of 0 0 0 0 0 1. Okay, and the last frame is not 249 but 250. Okay, that's what I mean. By the way, if we are here, let's take a look at the file name. As you can see, it contains the file name like close in this case, then contain an underscore, then 6 numbers, not matter how big the number is. 215 contains the same amount of number like 1. It's exactly 6 numbers. As you can see, the rest of the numbers will be filled with 0. So in this case there is 5 0 and then 1 1. And here there is just 3 0 and there is 250, so 250. Okay, now we have to make these file names first. Okay, by the way, we could make a very nice for loop which will do that, but I rather prefer a simpler solution. I will check that if it is less than 10, then I use 50 and the number. If it is so this I is between 10 and 100, then I use 40 and the number, and so on. I do that. Okay, so I go through all of the numbers, all of the frames, and now I have to create the file name which we will need. So I check if this I is less than 10. So if it is less than 10, then it is 1, 2, 3, 4, 5 through 9. Okay, in this case I use the sprintf function. We already used that in the past. This will basically print a string to so print a formatted string to a string. Oh, did I say that? I don't think so. So this will print it in the TMP. The format will be something like underscore and then 5 zeros, because in this case if there is so in this case if it is less than 10, there is 5 zeros behind the number, as you can see, 5 zeros, and then the numbers %sign D, because it is a decimal, and this decimal will be the I. So in this case, in the first case, it will run underscore 00001 and then underscore 00002 and so on. But if it is not less than 10, then I will check if it is less than less than 100. So if it is I less than 100, in that case we almost do the same thing, except there is one less zero. So there is one less zero. Okay, and then the 1000 comes. Okay, I just copy and paste it to save time. So if it is less than 1000, then there is one less zero. Okay, next one, and next one, and next one. Okay, and 10. Okay, and I add one more zero and one less zero, one more zero, actually two more zero, two less zero, and 3, I believe so. Not matter, no one will load as big things. Okay, and yeah, I believe so. This is it. Okay, now we have the good file name. For test reason, let's just write out this file name. So I use stdc out, so console output, and I write out this tmp. Okay, so tmp, and I use a new line here, so std_endl. So we will delete this obviously after this is work, just for test reason, because you know, I a lot of time make mistakes in this. Okay, so now we have the file name. So now it looks something like this, 000, and then no 55. Okay, I think this is 6. Yep, it is 6. Okay, and now we have to add the file name to it. The file name looks something like this, anim/close, and put the .obj after it. So now I will copy this thing we have just created after the file name, so it will look like something like this, and then I just simply copy the .obj after it. Actually, I will use a string for this, because I don't want to mess with this SDR_cat and SDR_copy and so on. So no, I don't really want to be with it. So I create a new string. This will be the tmp2, because what else could it be? And this will contain the file name. So the constructor will be the file name plus this tmp variable which we have created. So now I put the anim/close plus this whatever we created in here. Actually, you know what? We should write out this tmp2 instead of tmp. So I just write out this tmp2 and I add the .obj after it. So tmp2 plus equal .obj. I think it should work, because the plus equal is overloaded, so it is able to put so C style characters after it, so it's able to concatenate strings. Yeah, okay, so I will write out this tmp2, so if there is something problem, we know that there is a problem. Now we need to actually open this this file. So I use the obj.load function, and this obj.load is with the file name obviously, which will be tmp2. I believe we last time rewrote it, so it's with a string, if I remember well. Yet let me see. So okay, I can find it. Oh, there is it. So it waits a string, so we don't need to use the c_str member function to convert it to a C style string. Now actually it's loaded a variable, so this will be unsigned int and I call it id. So this will return with this id for the object we have loaded. And now I can just push back to this frames, the id. So frames dot push back, and I push back this id. Now these frames should contain all of the frames. So in this case it will contain 250 elements, and yeah, that's it. So now I believe there is nothing left. This is just this for loop. So I think we can try it out. Alright, so I go to the fur.cpp or main.cpp, whatever you like to call it, and actually I will load it somewhere. Okay, by the way, you may notice that this fur.cpp is very ugly now, because we use that for everything, to test and demonstrate everything. So it's pretty ugly. I don't really like it, but you know, I don't want to rewrite everything in every tutorial. Later on we will clear it when we actually make games or some other application, but for now you have to just accept like that. Okay, so I will create a global vector, so std vector, just for the sake of simplicity as always. So I call it unsigned int, and this will be called frames, because why not? Okay, this will contain the frames. So in here, in the init, actually in the end of the init, after the init skybox, I will load the animation. So load animation. Okay, this will wait the frames as the first parameter. Let me see the second parameter. This is the file name. This will be anim. I meant anim slash close. Okay, the next is next parameter is the number of frames. It's 250 if I remember well, and the last parameter is this obj loader. This is called obj, I believe so. Okay, then now this frames should contain all of the frames. Now I have to actually render these frames out. So I go down here after, so in the display function, so after this draw text thing, and I will display it. So gl call list. Oh, by the way, we need one more new variable. This is the current frame. So I create an int. I call it curFrame. I meant frame. Okay, and this is start from 0, obviously. Okay, and in the display function, I just call the list, which is frames curFrame, so current frame. Okay, and so obviously, oh, what am I doing? Now it is good. So I call the list. First of all, let me translate to somewhere. So I use the gl translate f, so it will be not inside those texts and planes which I have created. So this will be a little bit lefter. I believe the text was right, then this makes it left. So I will translate to, in the x coordinate I translate -10, 0, 0. I don't know if this -10 is enough or not. Maybe not, maybe enough, I don't know. Make it 20. Okay, so I will translate it to 20 at the -x direction, and I call this list. I believe this translation will not screw up everything after it, because this is the end of the function, and in the beginning of the function I use the load identity. So I will set back this translation. Okay, so I will load this current frame, and this should be in the main, but let me just create it here so it will be more understandable. So if this curFrame is greater than 250, then I just set back, oh, what this parenthesis right there. So I just set it back. So curFrame equal to 0. And actually this is, you know what, nope, 249. Yeah, that's it. And else I just increase it. So curFrame ++. Or let me think it over. In 200, no, I make an equal sign in here. So if we are in 249 exactly, then I set it back to 0. Else I set it, so I just increase it. I will increase it anyway. Oh, yep. Oh, fracking caps, control key still not working. I don't know why. Probably. Oh, that's right. So now if I increase the current frame, then in 249 and if it is equal, if it is greater than 249, then I've set it back to 0. I believe this will work and it will not left any frame out. Okay, and let me think, is there anything else? I don't believe so. So I think we are ready to try it out. Okay, I just get a terminal and I go back to my desktop and compile it. I hope there is a compile right here. I don't want to type it, this is a very long command. Okay, it seems that it's compiled. It's not guaranteed that it will work, but at least it's compiled. Okay, and now as you can see, it's loading the animation right here. Then try to write it. Okay, nothing moves. Maybe I export it wrong, or maybe I just screw it up. Okay, I will find out in a moment. So stay tuned. Oh, what have I done? Okay, I start to get old. You say now it will work, I believe. So what did I done? I don't know. I getting old, you know. So now I can try to run the program again. I still not try out so it is work or not, but at least this was a very okay. Here it is. The lighting is very screw up because of some reason. I don't know why. I believe it work. Just there is some problem with the lighting. I don't know what. Why is everything is not so smooth? I believe I don't turn on the flat rendering. Okay, now we can render an animation like this. We could render any kind of animation we want. So this was just a simple demonstration which kind of looks cool, but yes, you can use human models or weapon models or any kind of models which you want. Okay, and I think that is the end of the tutorial. I said this will be a very short tutorial, and thank you for watching and have a great day.